we're doing today and what we're starting today is kind of geometric proofs. So we're kind of writing a reason for every single step. So it's going to be similar to what we did with our algebraic proofs, but now we're talking about geometric lengths and segments and using our properties that we have to prove them and to prove something's true. Now with every one of these, there are going to be two things they give us. One's going to be the given, something that they give us and tell us. The other is going to be what we're wanting to prove. And what we're wanting to prove, so here we want to prove that AB is equal to BC, is going to be the last statement. Our last statement will always be what we're wanting to prove, what we're wanting to show, what we want to prove is true. So here they gave us that AC is equal to AB plus AB. They just told us that. They told us that this is true. And that's our first statement. I'll get a highlighter. So this is what they gave us, and this is our first statement. And we already have this down, yes? It's already down there. We're not having you write every single statement out, but we're filling in. We're filling in the blanks. Now, they want us to prove that AB is equal to BC. Our last statement, AB is equal to BC. So this is our start, this is our end point. Now, they gave us all of the statements. They already gave us the statements. We're just going to need to write the reasons why, so we can go from one to the next. Now, if we look at the second statement, so the first one's given to us. AC is equal to AB plus AB. They just told us that. Now, the second statement they have is that AB plus BC equals AC. So what is that saying? AB, so the distance from A to B, plus the distance from B to C, equals what? AC, the whole thing. Did we have a property that told us that? The two parts of a line segment added together equal the whole? Well, yes, it was our what? Segment addition postulate. Our segment addition postulate told us we can add two parts of the line together to get the whole. Our segment addition postulate told us that AB plus BC is equal to AC. And that's our segment addition postulate. So again, knowing these postulates or having them down and kind of referencing back to them is going to be crucial for this year. It's going to be knowing these postulates, or at least kind of having an idea and remembering what they are, because we are going to be using them. So AB plus BC equals AC, that's just our segment addition postulate. We used it in chapter 1. Now let's look at what's next. So any questions on 1 and 2, or kind of how we got this first part? Got a question? Okay. Any questions on anything we've done so far? Any questions on this here? Okay, let's look at what it says next. It says AB plus AB equals AB plus BC. Well, AB plus AB, that came from our first statement, yes? AB plus BC came from our second. And what were both of these equal to? AC, yes? It said AC equals AB plus AB. And then we said AB plus BC equals AC. So AC equals this. This is equal to AC, yes? What property did we have, or do we have, that relates kind of three things together? Because we're saying this is equal to that, and that is equal to this. So these two here are, yes. So transitive, yes, this is our transitive property of equality. Transitive property of equality. Because when we looked at the transitive property of equality, we were saying if A equals B and B equals C, then A equals C. A equals B, C equals A, because these are the same, so we hooked them together. Because they have something in common on both AC, on both of those two statements, and we set them equal, it's transitive. Transitive property of equality. So we're almost done, yes? Because we have two statements. Because we use the first two statements here to get this. AB plus AB, BC. Well, I'm close, aren't I? Because I do have AB on one side and BC on the other, yes? But what do they share? There's something else on either side that we have extra. What do we have extra on both sides of this line? We have an extra what? AB on both sides, yes? Is there a line above AB or any of those segments? So am I talking about a line segment? No, what are we talking about? We're talking about the measurement. Because when there's not a segment above AB or any of these letters, we're talking about the length. So really, AB and BC here are numbers. They're just represented by two letters, but it is a number, it is a value, yes? And if we have a value, what can I do to simplify from both sides? We can subtract it, yes? Because it'd be the same as this saying 7, wouldn't it? Because it's just a number. So what I can do is I can subtract it from both sides to go from here to here. We're just subtracting AB. We're subtracting AB from both sides, which is our subtraction property of equality, or subtraction property of equality. And that's all we did here. So the first thing that they did was they gave it to it. It was our given. The reason we can say AB plus BC equals AC is our segment addition postulate. That's the reason why we can say it, because again, a segment addition postulate says two segments on the same line added together give me the whole. Now the reason we use this or got the statement 3 is we can really combine statements 1 and 2. We combined statements 1 and 2 because they were both equal to AC to give us AB plus AB equals AB plus BC. And then we subtracted AB from both sides. Well, sorry, step 3 was our transitive property. The reason we could say that or combine the first two is our transitive property of equality. And then we subtracted AB from both sides because, again, it's shared on both sides. It's just a number. So it's our subtraction property of equality. And we're done. We proved that AB is equal to BC. And the main reason we can prove this is because it gave it to us that AB plus AB equals AC. If we weren't given that piece of information, we couldn't prove anything. So we're given something first. We're given something, some piece of information that we need to know. It can be given or it could be also drawn. The graph, the picture will have it too. And then we go through and prove it. Any questions on this here? If something doesn't make sense, you need to ask, you need to ask, you need to ask. Let's look at the next one. Let's look at this one here. Your pencil?
No, I got one. I'm just working.
Let's pay attention up here. Complete the steps. So we're going to complete this here. Now, hopefully what goes in line number 1, because we see that we're missing some parts of the statement. Yes? We have some blanks here. And we're going to fill those in to finish out this proof. Now, we're not going to work with a partner. We're going to work together. Now, again, as I said, there's going to be some stuff that is, there's going to be a main thing that's given, and there's going to be something we want to prove. There's going to be something that's given to us, and there's something that we want to prove. Now, what they told us is what? The measure of angle 1 is equal to the measure of angle 3. So we're going to fill that in because our given information always goes first. Our given information always goes first. Now, it told us the next two on both sides that EBA is 2 plus 3. it also told us that 2 plus 3, it also told us EBA is 2 plus 1. Because what did we say about angle 3 and angle 1? They were the same, yes? So we can alternate that. Now we got angle EBA is equal to 2 plus 3 because of our angle addition postulate. Because two angles added together give us the big one. So an angle can be split up into its two parts. We can add those together. Substitution property of equality. We substituted in that 1 is equal to 3. So we get this here. Angle 1, or angle 2 plus angle 1 equals the measure of EBA. So we have those two statements. Any questions on this so far? Any questions on any of this so far? Now we're looking at the next one, yes? Everybody's good to getting down to statement number 4, yes? Now if you have your reference sheet, and I would have it handy, just because we'll get used to looking at it, because you can have that reference sheet on the test. So I would be good, especially on the homework, referencing this, especially for 2.5, what we're doing today, and probably tomorrow possibly, and 2.6. I would be referring back to this and getting used to seeing what's on this and where it's at, okay? Now it says our reason for this step 4, whatever we're going to write here, is the commutative property of addition. And I believe commutative property of addition is on there. Yes? It's not on one side, it might be on the other. Commutative property of addition, and it might not be. Nope. Anybody see commutative property of addition? All right. I might have covered it up. Index. Reference. Commutative property of addition. Commutative property of addition is pretty much saying that we can add two things in any order. Commutative property of addition. Is that we can add these in any order. So really what this is saying is that the measure of angle 1 plus the measure of angle 2. They just switch the order. I just switched the order. Now that's not a big step, it's not a big deal, but it's saying we can switch the order. The measure of angle 1 plus the measure of angle 2. So it's just rewriting statement 3 with those just flipped. That's all it's saying. Commutative property of addition, we can add two things in any order. All it's saying is that 7 plus 4, like an example, would be the same as 4 plus 7. Commutative property of addition and multiplication. We can multiply any two things in any order, or we can add or subtract, or we can add two things in any order. Doesn't work with subtraction, but it does with multiplication and addition. Now, where are we going? EBA is equal to CBD. So our last statement, we're jumping past 5. Because this is where we want to end, yes? Because we always want to end, our last statement should be what we're wanting to prove. Our last statement should be what we're wanting to prove. And we're wanting to prove that these two angles are congruent. Huh? We'll get there. We're getting there. Because I want to show us this here, because this is where we're going, yes? This is where we're going. Now, we have one last one we're filling in. We're filling in 5. And so far, what have we said? We've said EBA is equal to 1 plus 2, yes? And we're wanting to prove CBD is equal to EBA. These two angles are equal, yes? Have we said anything about the other angle yet? No, we need to, yes? Now, what do we know about the measure of angle CBD? CBD. Well, it's adding what? This angle and this angle, yes? So the measure of angle 1 plus the measure of angle 2 is equal to the measure of what? Angle CBD, yes? And that would be it. Now, looking at this here, if you're wondering why did we do 1 plus 2, why did we rewrite it? Well, once we rewrote it as 1 plus 2, it shows us the same as step 5. Those are the exact same, yes? That's why we rewrote it. We rewrote it so that this here and this here were the same. And since they're the same, we can use that transitive property. We can use that transitive property. Now, we won't be as, on the test, I won't be as big of a nitpick about that, but it's nice to have so that we have it lined up. Questions on this here? Questions on anything so far? All right. We're looking at this here. Now, this one here, we don't have anything on either side. Now, a lot of the stuff we'll do, especially on the test or especially on the homework, is you're going to fill in like we've been doing. But here, we're going to do this one completely on both sides. Now, with any of these here, we start with what's given. We start with what's given. And our last statement should be what we're wanting to prove. We're always going to start with what's given, and we're going to finish with what we're wanting to prove. So what's given? Measure of angle 1 is equal to the measure of angle 3. And why do we know that? It's given. It's given. It's shown to us here. And our last statement, our very last statement, is that the measure of angle DBA is equal to the measure of angle EBC. That's going to be our last statement. However many statement that's going to be, it's going to be the very last one. So DBA is equal to EBC. So we want to show that. So looking at this here, kind of looking at what we're wanting to prove, and I'll draw this, I'll highlight our angles. Wanting to show that these two angles here are equal, yes? Because that's what it's showing. That's what it's telling us to prove, yes? What do they share? They share something in common, don't they? So what's an angle that these two angles share? Well, not an 80. There's a specific angle that DBA and EBC share. What do they share? Well, they share the vertex B, but what angle? 2. Is angle 2 in both of those? Yes. So one thing I'm going to say is that angle 2 is equal to the measure of angle 2. It's equal to itself, isn't it? Which is our what? The reflexive property of equality. Now that might seem redundant, but we're going to go on and state it. We're going to state that angle 2 is equal to the measure of angle 2. Because if that angle is equal to itself, that means I can add it. I can add it to both sides because it's equal, isn't it? Equal to itself. So I'm going to add it to the first statement on both sides. Because if I add it to one side, the measure of angle 1 plus the measure of angle 2 is going to equal the measure of angle 3 plus the measure of angle 2, yes? So I add it to both sides. So on one side I have 1 and 2, which gives me one of my angles, doesn't it? Because CBE is 1 plus 2. DBA is 2 and 3, yes? So I've almost gotten there, because we've said 1 and 2 does add together to give me one of the big angles. 2 and 3 adds together to give me the other big angle, yes? Did y'all agree with that there? So we're almost done, because we have the statement where we're saying those two angles are congruent, yes? Or equal? We have a few more steps. I think we have 3 more. Because have I defined either one of those angles yet? No. So let's say CBE. The measure of angle CBE is equal to the measure of what plus the measure of what? CBE is what and what? 1 and 2. CBE is 1 and 2, yes? The other angle, measure of angle EBC, that's not EBC. Back one. Forward one. One. EBC is equal to the measure of angle 1. Now the measure of angle DBA, the other angle, would be the measure of angle what? DBA. 3 and 2, yes? Any questions on anything we've done so far? Any questions on any of this here? Yep. Unfortunately, I've missed some of the reasons. So I got ahead of myself. So I'm going to pause here for a second, then we'll fill those in. But any questions on any of this here so far? Any questions on anything we've done so far? Yes, it'll be number 6. Yep, this last one here will be number 6. But any questions on how we did this here? Let's fill in our reasons. So number 3, what did we do to both sides? We added 2, yes? What property would that be? That would be our, well, what did we do? We added something to both sides, yes? Which would be our addition property of equality, because we're talking about something being equal. The 2 angles add together to be the whole would be our what? Segment, addition, postulate. And that's true for 4 and 5, because that's what we used, wasn't it? That the 2 angles add together to equal a whole. That's just the segment addition postulate. And what would be the last one? Huh? well, not proven, because we have to go, it wouldn't be division, because we said that these two here are equal by this one here, yes? To get this here. Now, I will take either transitive property of equality. I believe the textbook version would be the substitution property of equality. I will take either one. I'll take either one. Now, the textbooks is going to be, especially on your homework assignment, if we have something like this here, it's going to be substitution. Because the technical definition of this would be substitution. Because we're substituting this in for here and here. We're doing two steps in one. We're essentially saying we would substitute this in here, actually here. Let me make this easier to see. Okay. Any questions on this here before I kind of write out specifically what we did? We did two steps in one. Okay, good. Really what we would say is we could say that, we'll use this one here, dBA, is equal to the measure of angle 1 plus the measure of angle 2. Okay. This is the way that, this is another way we can do it. This is in your textbook. I'm just going to have you all look at this and walk through this. So there's more than one way to do this. 1 is equal to angle 3. That's what we said, yes? They said that the measure of angle dBA is 2 plus 3, yes? Because we said that also. Because again, that's angle addition postulate. Those two angles add together, give me the whole. Now they replaced 3 with 1. They substituted 3 and 1 because we said those two angles are equal, yes? So now we have dBA is equal to 1 plus 2. Well, angle 1 plus 2 is equal to EBC. And transitive, we can say they're equal. So that's another way we can do it. Does that make sense? So there's more than one way to do these proofs. It's just how are we walking through it? How are we going to walk through it? Questions on this here? So again, when you're doing these in the homework, it's going to be drag and drop. You're going to be filling in. You're going to be filling in. There's not going to be one of these here, and we're not going to ask you to do one completely that's blank. They'll be more like this here. Okay? So let's look at this next one. Now, 6 steps of a 2-column proof are shown. Copy and complete the proof. Now again, we start off with the given. We always start with the given. And what we want to end with is x equals 5. Yes? So they have the given and the what we're wanting to prove already filled in. But they didn't fill in the reason why t is the midpoint of SU. Why is that? It is given. Anything that's told to us is given. Anything that's told to us is given. ST is congruent to TU. Because our definition of a midpoint is the middle of a line segment. A midpoint of a line segment cuts the segment into 2 what? Congruent parts, yes? The definition of a midpoint is it cuts the segment into 2 congruent parts. It doesn't say that they're equal. They said that they were what? They are congruent, yes? It doesn't say they're equal. They said they're congruent. But what do we know about congruency? Two things are congruent, have the same measure, yes? That's why we go to step 3. Step 2 says that they're congruent Because they're congruent, we can say that they're equal. Because they're congruent, we can say that they're equal. Definition of congruent segments. That's how we can say that. So if we have a definition, like definition of perpendicular lines, perpendicular lines meet at right angles. So how do we know two lines are perpendicular? If they meet at right angles. So we can use the definitions. Now that brings us to the next one. 7x equals 3x plus 20. So what are we doing? Well, we know ST is 7x, yes? Because it told us up here, I mean, it's 7x, 3x plus 20. So this here, our substitution property, because we're substituting in the values of ST and TU, we're substituting those values in. We're substituting them in. Now, we don't have a specific value, but we have a specific equation that we're substituting those in for, that we're plugging those in for, that we have those values of. Substitution. Subtraction property of equality. So this gave us a hint for the next one, yes? Gave us a hint. It gave us subtraction property of equality. So let's ignore that. So 7x equals 3x plus 20. I need to get the value of x by itself, yes? So what would we do to get x by itself? We would subtract 3x from both sides. Because on one side we're going to get 20. Here we're going to have what? 7x minus 3x, yes? What's 7 minus 3? So we should have 4x is equal to 20. Yes? Huh? Then we would divide both sides by 4, yes? And when I divide both sides by 4, I get x is equal to 5. And that would be our what? Division property of equality. That'd be our division property of equality. And that's it. We filled everything in. We have filled all of these pieces of information in. Properties of segment and angle congruency. So we have reflective, symmetric, and transitive properties of congruency. Now, congruency is saying that talking about two angles that are congruent or similar. Not similar, they're congruent. They have the same shape. So it's almost the same as equality, but we're not talking about the measure of the length or the measure of the angle. We're talking about the angle itself or the length itself. We're talking about the segments here, not their measure. So I'd go on and get these down here. So reflexive for any segment AB, AB is congruent to AB. Any segment's congruent to itself. Symmetric, if AB is congruent to CD, then CD is congruent to AB. Yeah, so these here are also, I believe, on your reference sheet, yes? Equality, congruency. So they're on there for your congruency. They're on your reference sheet. But I'll give you a little bit here to write those down.